the left hand limit is equal to right hand limit is equal to functional value. If such is the case, find out the value of k. D by dx of x to the power of n is nx to the power of n minus 1, where n is a rational number. Tan x is the inside function. Differentiation of secant x is secant x tan x into d by dx of tan root x. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty department of mathematics, Vidhyaashram PU College, the temple of excellence. Today I am going to take very important class, that is the revision on continuity and differentiability. So the first chapter in calculus, this is very important chapter. Now let me discuss the weightage for this. So for this academic year 2022, so the weightage for this marks is you will get 2 1-mark questions and 3 2-mark questions and 3 3-mark questions and 1 4-mark question and 1 5-mark question from first part, that is continuity and differentiability. So the total weightage for this chapter is 26 marks. Practice this chapter, definitely you will get the maximum marks from this chapter. So here the 1 4-mark question is from part E. For part E, 1 6 plus 4 marks. So this 4 marks may be from continuity, and the remaining this 5 marks is from second derivative. So you will expect a question from second derivative for 5 marks, and the remaining are all from composite function, function of a function, then parametric functions, implicit functions, logarithmic functions and exponential functions. So let us discuss in detail. Now first let us come to the continuity, first part, the continuity. Now what is a continuous function? Before going to the continuity, let us know regarding the definition of a limit. Now what is the definition of a limit? A function y is equal to f of x is said to be tends to a limit L. A function y is equal to f of x is said to be tends to a limit L as x tends to a. So f of x is said to be tends to a limit L as x tends to a if the numerical difference between f of x minus L mod can be made as small as possible by taking x nearer and nearer to a. If x is nearly equal to a, then this value f of x is nearly equal to L, and it is denoted as limit x tends to a of f of x is equal to L. That is, a function f of x is said to be tends to a limit L as x tends to a if the numerical difference between f of x minus L can be made as small as possible by taking the value of x which is nearly equal to a, and it is denoted as limit x tends to a of f of x is equal to L. So therefore limit x tends to a of f of x is nearly equal to L. That means the value of f of x is nearly equal to L when x is nearly equal to a, and it is denoted as limit x tends to a of f of x is equal to L. Now you might have been studied regarding left hand limit as well as a right hand limit. So suppose if limit x tends to a minus f of x, this is called the which tends towards the negative, towards the left side, that is left hand limit, and the limit x tends to a plus denoted as f of x is called the right hand limit of a function. Now let us come to the concept. Suppose if f is a real valued function and c be the point in the domain of f, then f is continuous at the point c. See here, if f is a real function and c be a point in the domain of f, then f is continuous at x is equal at the point c if the limit x tends to a of f of x is equal to f of c. What is the meaning? In general, the left hand limit LHL and the right hand limit RHL of the function which is equal to the value of the function at x is equal to c, if these three exist and equal, then it is said to be continuous at c. That means a function f of x is said to be continuous at x is equal to c if left hand limit is equal to right hand limit is equal to functional value. That is, left hand limit is equal to right hand limit is equal to functional value. That is, if limit x tends to a minus f of x is equal to limit x tends to a plus f of x is equal to the functional value. If these three are equal, then the function f of x is said to be a continuous function. Otherwise, if not equal, then it is called a discontinuous function, not continuous. Now, see here, Hence, a function is continuous at x is equal to c if the function defined at x is equal to c, and if the value of the function at x is equal to c is equal to the limit of the function at x is equal to c, then it is called continuous function. If it is not equal, then it is called discontinuous. So we say that f is not continuous at c or discontinuous at c, and c is called the point of a discontinuity of the function f. Now let us verify one problem. Check the continuity of the function f is given by f of x is equal to 2x plus 3 at x is equal to 1. Now what is given here at x is equal to 1? X is equal to 1, that is a is equal to 1. At x is equal to 1, f of x is given to be 2x plus 3. Now find out the limit. So limit x tends to a of f of x is equal to limit x tends to, what is a here? A is equal to 1 and f of x is equal to 2x plus 3. Substitute the value of x is equal to 1, put x is equal to 1, 2 into 1 is 2 plus 3 is equal to 5. The value of limit is equal to 5. When x is equal to 1, f of x is equal to 2x plus 3. Now therefore find out the value of f of a, that is f of 1, that is 2 into 1 plus 3 is equal to 5. So here limit x tends to a of f of x is equal to f of a. 5 is equal to 5. Therefore f of x is continuous at x is equal to 1. So the function is continuous at x is equal to 1. See here, limit x tends to a of f of x is equal to f of a. So therefore the given function f of x is equal to 2x plus 3 is continuous at x is equal to 1. That's it. Okay. Now let us come to the exact problem. Now what is given here? Show that f of x is equal to x cube plus 1 if x is not equal to 0. 1 if x is equal to 0 is not continuous at x is equal to 0. We have to verify whether this is not continuous. So we have to prove this is not continuous. That means left hand limit is not equal to right hand limit is not equal to functional value. Just find out the limit and the functional value. Now what is given at x is not equal to 0? At x is not equal to 0 means x is less than 0 or x is greater than 0. Now that means this is equal to the limit. Limit x tends to 0 of f of x is equal to limit x tends to 0 of f of x. What is f of x here? X cube plus 3. What is the value of a? A is equal to 0. So just substitute the value, put x is equal to 0. 0 cube plus 3 is equal to 3. The value of the limit is 3. Now the functional value. When x is equal to 0, what is given? F of x is equal to 1. So f of 0 is equal to 1. See here, limit x tends to a of f of x is not equal to the functional value. Limit value is equal to 3 and the functional value is equal to 1. They are not equal. So therefore f of x is not continuous at x is equal to 1. So this is discontinuous. So the given function is not continuous. Just by looking to the problem, you can say put x is equal to 0. 0 cube is 0 plus 3 is 3 and the value of the function is 1. 3 is not equal to 1. So therefore this is not continuous. Right. Now let us come to the next problem. Let us check this. Check the continuity of the function. So if f of x is equal to x plus 2, if x is less than or equal to 1, x minus 2 if x is greater than 1, check the continuity of the function at x is equal to 1. Let us verify this. Now, when x is less than 1, what is f of x? F of x is equal to x plus 2. So, we will get left hand limit. Limit x tends to a minus f of x. What is a here? A is equal to 1. So, limit x tends to 1 of f of x. What is f of x is? X plus 2. Put x is equal to 1 plus 2 is equal to 3. Now, when x is greater than 1, what is f of x? F of x is equal to x minus 2. Greater than 1 means you will get right hand limit. Right hand limit is equal to limit x tends to a plus f of x is equal to limit x tends to 1 of f of x is x minus 2. That is 1 minus 2 is equal to minus 1. Now, when x is equal to 1, f of x is equal to, what is f of x? X plus 2. So put x is equal to 1. 1 plus 2, this is equal to 3. Now verify whether left hand limit is equal to right hand limit is equal to functional value. What is left hand limit? Left hand limit is equal to 3. And what is right hand limit? Right hand limit is -1 and the functional value is equal to. So these are not equal. Left hand limit is not equal to right hand limit is not equal to functional value. Therefore, f of x is not continuous at x is equal to 1. This is not continuous at x is equal. This is discontinuous. So that is how we are going to check the continuity of the function. Okay. Hope you followed. Now let us come to the next problem. Now in general, a function f of x is said to be continuous at x is equal to a if limit extends to a minus f of x is equal to limit extends to a plus f of x is equal to f of a. That is left hand limit is equal to right hand limit is equal to functional value. So if left hand limit is equal to right hand limit is equal to functional value, then f of x is continuous. So if they are not equal, if left hand limit is not equal to right hand limit not equal to functional value, then it is a discontinuous function. Discontinuous function. Now let us discuss the exact important problems on this. Now these are very important type of problems for the point of examination for 4 marks. Now show that the function f of x is equal to x plus 1 if x is greater than or equal to 1, x square plus 1 if x is less than 1 is continuous at x is equal to 1. Now let us take when what is given x is equal to 1 means the value of a is equal to 1. When x is less than 1, what is f of x? When x is less than 1, f of x is x square plus 1. So we will get left hand limit is equal to limit extends to a minus f of x. That is limit extends to a is 1, f of x is x square plus 1. Now put the value of x is equal to 1, 1 square plus 1, that's equal to 1 plus 1 is equal to 2. When x is less than 1, f of x is equal to 2. When x is greater than 1, what is f of x defined? F of x is equal to x plus 1. So you will get right hand limit is equal to limit extends to a plus f of x, that is limit extends to 1 plus f of x. What is f of x here? F of x is equal to x plus 1. Put x is equal to 1. 1 plus 1, this is equal to 2. Left hand limit is equal to 2. Right hand limit is equal to 2. Now come to the functional value. When x is equal to 1, what is f of x? When x is equal to 1, f of x is x plus 1. So f of a. F of a means f of 1 is equal to 1 plus 1 is equal to 2. See, left hand limit is 2, right hand limit is 2, functional value is 2. So therefore this is continuous. So just write left hand limit is equal to right hand limit is equal to functional value. What is left hand limit? 2. What is right hand limit? 2. What is functional value? 2. So since left hand limit, right hand limit are equal and equal to functional value, so therefore f of x is continuous. F of x is continuous at x is equal to 1. So if you do this much, definitely you will get 4 marks. This is how we are going to solve. Okay. Now let us come to the next problem. So these type of problems are very important. Definitely you may expect this type of question for your 2022 examination for 4 marks in part E. Now come to this problem. Find the value of k. Finding the value of k so that the function f is continuous at x is equal to 5. See, it is already given. The function is continuous at x is equal to 5. What is required to find is k. What is given? The left hand limit is equal to right hand limit is equal to functional value. If such is the case, find out the value of k. Very simple problem. Just find out the value of limit first. Left hand limit. Find the value of k so that the function f is continuous. X is equal to 5 means given. What is the value given? A is equal to 5. At a is equal to 5. What is defined here? At a is 5. That is when x is less than 5, f of x is kx plus 1. X is greater than 5, f of x is 3x minus 5. If x is equal to 5, it is kx plus 1. Since this is continuous, find out the value of k. Just find out the value of left hand limit, right hand limit and functional value. Equate it, you will get the answer. That's it. Now, let us come to the first concept. When x is less than 5, what is f of x? When x is less than 5, f of x is equal to kx plus 1. So, you will get left hand limit is equal to limit extends to a minus f of x. So, this is limit x tends to a. What is a? 5 minus f of x. F of x is kx plus 1. Put x is equal to 5, then this become 5k plus 1. Second one, when x is greater than 5, when x is greater than 5, f of x, what is f of x? 3x minus 5. So you will get right hand limit. Right hand limit is equal to limit x tends to a plus f of x. So this is limit x tends to 5 plus f of x is 3x minus 5. So this is equal to, just put x is equal to 5, 3 into 5 minus 5, 15 minus 5, this is equal to 10. So right hand limit is 10, left hand limit is 5k plus 1. Further, when x is equal to 5, when x is equal to 5, the functional value f of x is equal to kx plus 1, kx plus 1. Put x is equal to 5, this is f of 5 is equal to 5k plus 1. Since f of x is continuous at x is equal to 5, therefore left hand limit is equal to right hand limit is equal to functional value. Now what is left hand limit? Left hand limit is 5k plus 1, 5k plus 1. Right hand limit is equal to 10. Again functional value is also equal to 5k plus 1. So 5k plus 1 is equal to 10 is equal to 5k plus 1. You can equate first and second or second and last. Let us equate these two. 5k plus 1 is equal to 10. 5k is equal to 10 minus 1 is 9. Therefore, k is equal to 9 by 5. This is the answer. So if you do this much, definitely you will get 5 marks. So, therefore, the value of k is equal to 9 divided by 5. Very important. You may expect this type of problem for your 4 marks question in the final examination. So, just find out LHL, RHL and a functional value. Subsequate it, you will get the answer. That's it. Hope you followed. Let's come to the next problem. This is also very important. You may expect this also for your 2022 examination. Find the value of k if f of x is continuous at x is equal to pi. So here it is given already. So at x is equal to pi, here a is equal to pi. Now at x is less than pi, at x is less than pi, f of x is equal to kx plus 1. So we will get left hand limit. Left hand limit is equal to limit x tends to a minus f of x. This is limit x tends to pi of kx plus 1. Put x is equal to pi. So then this becomes k into pi plus 1. Left hand limit. Again, when x is greater than pi, when x is greater than pi, f of x is defined as cos x. Now, so you will get right hand limit. Right hand limit is equal to limit x tends to a plus f of x, that is limit x tends to pi plus f of x is cos x. So this is equal to cos pi. Cos pi is equal to minus 1. Cos 180 is minus 1. Again, when x is equal to 1, at x is equal to pi, what is f of x? At x is equal to pi, f of x is kx plus 1. Now, therefore, the functional value f of a is equal to f of pi. This is equal to k into pi plus 1. Okay. Now, what is given? Since f of x is continuous at x is equal to pi, that means left hand limit is equal to right hand limit is equal to functional value. What is left hand limit? K into pi plus 1. Right hand limit is minus 1 and the functional value is equal to k into pi plus 1. Same as that of the previous problem. Just equate first and second or second and last. Let us equate these two. K into pi plus 1 is equal to minus 1. K into pi is equal to, transfer this plus 1 becomes minus 1. Minus 1 is minus 2. Therefore, k is equal to minus 2 divided by pi. So, therefore, k is equal to minus 2 divided by pi. This is the answer. Very important. So, here k is equal to minus 2 by pi. That's it. Very important problem. Hope you followed. Just practice. Definitely you will get this type of problem for 4 marks. Maximum type they will ask this type of questions only. Okay. Now, let us come to a similar problem. Now, find the value of k if f of x is equal to kx square if x is less than or equal to 2, 3 if x is greater than or equal to 2 is continuous at x is equal to 2. So, this method to solve this also, like this you can solve. What is given here? Since f of x is continuous at x is equal to 2, therefore left hand limit is equal to right hand limit is equal to functional value f of a, that is f of 2. Now, what is left hand limit? Straight away we can write limit x tends to 2 minus f of x. When x is less than 2, f of x is kx square is equal to right hand limit, limit x tends to 2 plus f of x. When x is greater than 2, it is 3, and the functional value when x is equal to 2, this is kx square at x is equal to 2. This is given. Left hand limit is equal to right hand limit is equal to functional value. So, put x is equal to 2, this is 3, again k into 2 square. So, 4k is equal to 3 is equal to 4k. Equate it, just therefore 4 into k is equal to 3, therefore k is equal to 3 by 4. That's it. The value of k is equal to 3 by 4. So, this method also you can use. You can follow this method also. Instead of finding LHL, RHL, functional value separately, straight away put, since it is continuous, left hand limit is equal to right hand limit is equal to functional value. Left hand limit is k into x square, right hand limit, that is 3 already given, and the functional value is k into x square at x is equal to 2. So, 4k, 3 is equal to 4k, 4k is equal to 3, therefore k is equal to 3 by 4. That's it. Okay. Now, let us come to next problem. Now, this is also a very important problem indeed. Now, what is given? Find the value of k if f of x is equal to k into cos x divided by pi minus 2x if x is not equal to pi by 2. 3 if x is equal to pi by 2 is continuous at x is equal to pi by 2. Now, what is given here? The value of a is equal to pi by 2. Okay. Since x is not equal to pi by 2, x is not equal to pi by 2 means x is less than pi by 2 or x is greater than pi by 2. So, that means left hand limit and right hand limit are same here. So, therefore, limit x tends to a of f of x is equal to f of a. This is given because since f of x is continuous at x is equal to pi by 2. Since f of x is continuous at x is equal to pi by 2, so therefore limit x tends to f of x is equal to f of a. Now, substitute the value, that is limit x tends to, what is a here? Pi by 2. Limit x tends to pi by 2 of f of x is k into cos x divided by pi minus 2x is equal to, the functional value is 3. That's it. Simplify this, you will get the answer. See, since f of x is continuous at x is equal to pi by 2 means, since x is not equal to pi by 2 means that is nothing but less than pi by 2 or greater than pi by 2. So, therefore, limit x tends to f of x is equal to f of a, x tends to, limit x tends to a, what is a? Pi by 2 of f of x is k into cos x divided by pi minus 2x is equal to 3. Now, simplify this. Let us go to the next page. Now, this is limit x tends to pi by 2 of k cos x divided by pi minus 2x is equal to 3. Now, let us simplify this. Limit x tends to pi by 2 of k into, convert cos, since you know the formula, since cos theta is also equal to sin 90 minus theta. Okay. Sin 90 minus theta is cos theta. So, this cos x can be written as sin of 90 minus x divided by, see here, sin 90 minus x is cos x divided by, you can divide by 2, you can take 2 out, then this is pi by 2 minus x is equal to 3. Just multiply, see, if you multiply 2 and 2 gets cancelled, pi minus 2 into x is 2x. So, this k by 2 is constant, take k by 2 out. What is left over is limit x tends to pi by 2 of sin pi by 2 minus x divided by pi by 2 minus x is equal to 3. Now, this k by 2 as it is. Now, how to evaluate this? So, this can be evaluated by taking the substitution. Put theta is equal to pi by 2 minus x. So, then this reduces to Sin theta divided by theta. Now, whenever the substitutions are taken, the value of limit also changes. See here, when x tends to pi by 2, x tends to pi by 2 implies theta is equal to pi by 2 minus pi by 2 is equal to 0. Theta tends to 0. See, let us take the substitution, put pi by 2 minus x is equal to theta. Whenever the substitutions are taken, the value of limit also changes. When x is equal to pi by 2, theta is equal to pi by 2 minus pi by 2 is equal to 0. Therefore, this becomes k by 2 into limit x tends to pi by 2 converts to theta tends to 0. See, x tends to pi by 2 becomes theta tends to 0, and this is sine of pi by 2 minus x is nothing but theta divided by again pi by 2 minus x is theta is equal to 3. Since you know the standard result, that is limit theta tends to 0 of sine theta by theta is equal to 1. Since limit theta tends to 0 of sine theta by theta is equal to 1. So, therefore, this can be written as k by 2 into sine theta by theta is 1 is equal to 3. Cross multiply, k by 2 into 1 is k by 2. K is equal to 3 into 2, that's equal to 6. So, therefore, the value of k is equal to 6. So, here this is very important, the value of k is equal to 6, that's it. Okay, hope you followed. Let me explain once again. Since left hand limit and right hand limit are equal here, that is limit extends to a of x equal to f of a, limit extends to pi by 2 of k cos x divided by pi minus 2x is equal to 3, and this can be written as cos x can also be written as sin 90 minus x, because sin 90 minus theta is cos theta, and just take 2 out, divide by 2 or take 2 out, 2 into pi by 2 minus x. So, this can be written as pi by 2 minus x. If you multiply, you will get the same thing. So, this is of the form sin theta by theta, converted by taking the substitution, put theta is equal to pi by 2 minus x. Whenever the substitution is taken, the value of limit also changes. So, k by 2 into x tends to pi by 2 becomes theta tends to 0, sine of pi by 2 minus x is theta, divided by pi by 2 minus x is theta. This is how the form sin theta by theta is 1, k by 2 into 1 is equal to 3, or k is equal to 3 into 2 is 6. Therefore, the value of k is equal to 6. That's it. Okay. Hope you followed. Very important type problem. Now, let us come to the similar type problem. This is also very important. Find the relation between a and b so that the function defined by f of x is ax plus 1 if x is less than or equal to 3, bx plus 3 if x is greater than 3 is continuous at x is equal to 3. This is given continuous at x is equal to 3. Okay. Now, let us write down a is equal to 3. When x is less than 3, f of x is equal to ax plus 1. So, therefore, left hand limit extends to a minus f of x, that is limit extends to 3 minus f of x is ax plus 1, put x is equal to a, then this is 3a plus 1. Similarly, when x is greater than 3, f of x is equal to bx plus 3. So, you will get right hand limit is equal to limit extends to a plus f of x, that is limit extends to 3 plus f of x is bx plus 3, put x is equal to 3 into b plus 3. Okay. Now, since what is given when x is equal to 3, the functional value f of x is equal to ax plus 1, that is f of 3 is equal to 3a plus 1. What is given? Since f of x is continuous at x is equal to 3, since f of x is continuous at x is equal to 3, therefore, left hand limit is equal to right hand limit is equal to functional value. Left hand limit is equal to right hand limit is equal to functional value. What is left hand limit? 3a plus 1. Right hand limit is 3b plus 3 is equal to the functional value. Functional value is also equal to 3a plus 1. Now, equate these two. Now, from this 3a plus 1 is equal to 3b plus 3. Okay. Now, just transfer this. 3a is equal to 3b plus 3 minus 1, that is 3b plus 2. Divide by 3. Then a is equal to b plus 2 by 3. This is the relation. So, a is equal to b plus 2 by 3 is the relation between A and B. What is to get here is find the relation between A and B, means A is equal to B plus 2 by 3 is the relation. That's it. Hope you followed. Okay. Now let us come to the next problem. Same. Find the values of A and B is to be determined so that the function defined by f of x is equal to 5 if x is less than or equal to 2, ax plus b if x is in between 2 and 10, and 21 if x is greater than 10 is continuous function. So there are two values of A are defined when x is less than, when at x is equal to 2 and x is equal to 10, you have to verify. Now let us consider at x is equal to 2. Well, so when x is less than 2, what is the functional value? F of x is equal to 5. So you will get left hand limit is equal to limit extends to a minus f of x, that is limit extends to 2 minus 5, this is equal to 5. Now when x is greater than 2, when x is greater than 2 means f of x greater than 2 means this f of x is equal to ax plus b. So you will get the right hand limit. Right hand limit is equal to limit extends to a plus f of x. So this is limit extends to 2 plus what is f of x here? Ax plus b. Put x is equal to 2. So 2a plus b. And when x is equal to 2, the functional value itself is 2. Okay. Now therefore when x is equal to 2, f of a is equal to 5, that is f of 2 is equal to 5. So therefore left hand limit is equal to right hand limit is equal to functional value. That means what is left hand limit here? 5 is equal to the right hand limit is 2a plus b is equal to 5. So you can get 2a plus b is equal to 5. This is equation number 1. Now simplify, you will get equation number 1. See here, first at x is equal to 2, find out the left hand limit, right hand limit and the functional value. Since this is continuous at x is equal to 2, so therefore left hand limit is equal to right hand limit is equal to functional value. 5 is equal to 2a plus b is equal to 5. So therefore we will get the first equation 2a plus b is equal to 5. Similarly at x is equal to 10, simplify, you will get the equation number 2. Now at x is equal to 10, now second part, at x is equal to 10, the left hand limit is limit extends to 10 minus f of x, this is equal to limit extends to 10 minus f of x. When x is less than 10, f of x is, this is ax plus b. Put x is equal to 10, this is 10a plus b. Similarly the right hand limit is equal to limit extends to 10 plus f of x is equal to limit extends to 10 plus what is the value of f of x? So when x is greater than or 10, this is 21. So this is equal to 21. Again the functional value f of a or f of 10 is equal to, when x is equal to 10, that is at x is equal to 10, you will get f of 10 is equal to 21. Since what is given here also, the function is continuous at x is equal to 10, so left hand limit is equal to right hand limit is equal to functional value, that is 10a plus b is equal to 21 is equal to 21. So therefore 10a plus b is equal to 21. Let us consider this as equation number 2. Now solving 1 and 2, what is equation number 1? 2a plus b is equal to 5. Solving equations 1 and 2. What is equation number 1? 2a plus b is equal to 5. And equation number 2, this is equation 10a plus b is equal to 21. Just subtract this. This is minus, minus and minus. Plus b minus b cancel. 2 minus 10 is minus a is equal to 5 minus 21 is minus 16. A is equal to minus 16 by minus 8 is plus 2. So therefore a is equal to 2. A is equal to 2. Substitute this value of a in any one of these two equations. From 1, b is equal to 5 minus 2a. What is equation number 1? 2a plus b is equal to 5. B is equal to 5 minus 2a. So this is 5 minus 2 into a is 2. 5 minus 4 is equal to 1. So therefore b is equal to 1. So what is the conclusion part? Therefore for this a is equal to 2 and b is equal to 1. That's it. A is equal to 2 and b is equal to 1 are the values of a and b. So this is also very important problem. Okay. So this is how we are going to solve the problems for 4 marks in continuities. These type of problems are very important for 4 marks. Okay. Now let us come to the second part, that is differentiability. So you might have been studied regarding the standard results in derivatives from first PUC itself. Now let us recall those things. D by dx of x to the power of n is nx to the power of n minus 1, where n is a rational number. Now let us come to this. Derivative of x is equal to 1. D by dx of x is 1. D by dx of x square, n is equal to 2. X to the power of 2 minus 1 is 2. X to the power of 1, that's equal to 2x. Derivative of x cube, what is n? N is equal to 3. X to the power of 3 minus 1 is 3x square. So differentiation of x cube is 3x square. Whereas derivative of a constant is 0. And these are the standard result. D by dx of root x is 1 over 2 root x. D by dx of 1 by x is minus 1 by x square. And the derivative of e to the power of x is e to the power of x. See here, d by dx of 1 over x can be written as d by dx of x to the power of minus 1. What is n? N is equal to minus 1. X to the power of minus 1 is minus 2. Bring this to the denominator, minus 1 by x square. Similarly, d by dx of root x can be written as d by dx of x to the power of 1 by 2. What is n? 1 by 2 x to the power of 1 by 2 minus 1. This is equal to 1 by 2 x raised to minus of. Bring this to the denominator. 1 over x raised to plus of is 1 over 2 root x. That's it. Just keep it in mind. D by dx of root x is 1 over 2 root x. D by dx of 1 over x is minus 1 by x square. And d by dx of e to the power of x is e to the power of x itself. And whereas for some trigonometrical functions, d by dx of log x is 1 over x. Differentiation of log x to base is 1 over x. D by dx of sin x is cos x. D by dx of cos x is minus sin x. Differentiation of tan x is secant square x. D by dx of cosecant x is minus cosecant x into cot x, and d by dx of cot x is minus cosecant square, and d by dx of secant x is secant x into tan x. See here, differentiation of log x is 1 over x, sin x is cos x is minus sin x, tan x is secant square x, and d by dx of cot x is minus cosecant square x, d by dx of secant x is secant x tan x, and d by dx of cosecant x is minus cosecant x cot x. So the very important formula is this d by dx of x to the power of n is nx to the power of n minus 1, where n is a positive integer, negative integer, or a fraction, positive or a negative fraction. Now, and also you might have been studied regarding the product rule and the quotient rule. Now, the product rule is d by dx of u into v is equal to u into dv by dx plus v into du by dx. First function into differentiation of second function plus second function into differentiation of first function. And you might have been studied this also, d by dx of u by v, numerator divided by the denominator, denominator into differentiation of numerator minus numerator into differentiation of denominator divided by denominator square. So these are few concepts you might have been studied in your first PUC and your previous classes. Now straight away come to the next concept, that is derivative of composite function, function of a function. Now composite function, functions of the function of function is called a composite function. To differentiate a composite function, we are going to apply the chain rule. So if one function, to differentiate a composite function, we are going to apply the chain rule, that is d by dx of f of x to the power of n. D by dx of f of x to the power of n is always equal to n into f of x to the power of n minus 1 into d by dx of that inside function. This is the formula. D by dx of f of x to the power of n is n into f of x to the power of n minus 1 into d by dx of f of x. Now, let us come for example. Let us take for example d by dx of 3x square plus 1 whole raised to 4. This is f of x to the power of n. What is n? N is 4 into 3x square plus 1 whole to the power of 4 minus 1 into d by dx of inside function, that is 3x square plus 1. So this is 4 into 3x square plus 1 whole to the power of 3. 4 minus 1 is 3 into 3 as it is. Differentiation of x square is 2x. So if you want, you can multiply. This can also be written as 4 into 3x square plus 1 whole cube into 3 2s are 6x. or if you want, you can multiply 6 4s are 24x into 2x square plus 1 whole cube. This is how we are going to differentiate. So d by dx of f of x to the power of n is n into f of x to the power of n minus 1 into d by dx of f of x. Okay, let us take few problems. Usually you will get one mark question from this concept. So 1 mark. So that is, let us explain the chain rule once again. The composition function of a function is called the composition function. Or to differentiate the composite function, we are going to apply the chain rule, that is d by dx of f of x to the power of n is n into f of x to the power of n minus 1 into d by dx of f of x. Okay, now let us take an example, same problem which I solved now. So that is, differentiate this d by dx of 2x plus 1 whole cube, n is equal to 3 into 2x plus 1 whole to the power of 3 minus 1 into d by dx of inside function 2x plus 1. So this is 3 into 2x plus 1 whole square. 2 into differentiation of x is 1. So multiply this, 3 into 2 is 6 times 2x plus 1 whole square. That's it. See here, f of x 2x plus 1 whole to the power of n into f of x to the power of n minus 1 into d by dx of inside function 2x plus 1. So 2 constant, differentiation of x is 1, 1 into 2 is 2, 2 into 3 is 6 times 2x plus 1 whole square. Now come to this. So this, let us consider this as x. Dy by dx is equal to d by dx of tan of 2x plus 3. Now this is x. What is differentiation of tan x? Secant square x. Secant square, instead of x it is 2x plus 3 into d by dx of 2x plus 3. Okay. So this is secant square of 2x plus 3 into differentiation of 2x is 2. So secant square 2x plus 3 into 2 is the differentiation of tan of 2x plus 3. Differentiation of tan is secant square 2x plus 3 into d by dx of 2x plus 3 is 2. So secant square 2x plus 3 into 2. Now let us take few problems. So differentiate the following with respect to x. So these are all 1 mark questions. So you may expect this type of problems in your 1 marker. Now what is here? Now let us consider y is equal to sine of x square plus 5. Differentiating with respect to x, dy by dx is equal to d by dx of sine of x square plus 5. Let us call it as x. What is differentiation of sine x? Cos x, instead of x it is x square plus 5 into d by dx of x square plus 5. So this is equal to cos of x square plus 5 into differentiation of x square is 2x. That's it. See here, let us call it as x. Differentiation of sine x is cos x. What is x? X is nothing but x square plus 5 inside function into d by dx of inside function is x square plus 5. Differentiation of x square is 2x, 5 constant 0, 2x into cos of x square plus 5. Similarly, let us come to this problem. Y is equal to cos of sine x. Differentiating with respect to x, if you differentiate this with respect to x, dy by dx is equal to d by dx of cos of sine x. You know, let us call it as x. What is differentiation of cos x? Minus sine x, sine of sine x into d by dx of sine x. That's it. So this is equal to minus sine of sine x into differentiation of sine x is cos x. That's it. See here, let us assume this as x. Differentiation of cos x is minus sine x, sine of sine x into d by dx of sine x is cos x, minus sine of sine x into cos x. Okay. Now let us take one more problem. Differentiate the following with respect to x. Same 1 mark question. So if you differentiate this, differentiating with respect to x, so let us call it as y. So dy by dx is equal to d by dx of sine of ax plus b. Now this is nothing but x. Differentiation of sine is cos ax plus b into d by dx of inside function, that is ax plus b. So this is cos of ax plus b into a constant, differentiation of x is 1 plus b constant 0. So therefore you can write dy by dx is equal to a into cos of ax plus b. That's it. So d by dx of differentiation of sine ax plus b is a cos ax plus b. Similarly, consider this, y is equal to secant of tan root x. So differentiate it, dy by dx is equal to, let us assume this as secant x. Differentiation of secant x is secant x tan x, secant x into tan x tan root x into d by dx of tan root x. This is function of a function of a function. Here tan x is the inside function. Differentiation of secant x is secant x tan x into d by dx of tan root x. So this can be written as secant of tan root x into tan of tan root x into differentiation of tan root x is secant square root x into d by dx of root x is 1 over 2 root x. This is the simplified answer. So how to differentiate tan? Differentiation of tan is secant square, instead of x it is root x, into d by dx of root x is 1 over 2 root x. Hope you followed. Okay. Now let us come to the next problem. What is the next problem? Y is equal to 2 root cot x square. Now differentiate this. Dy by dx is equal to 2 into, this is root x. Differentiation of root x is 1 over 2 root x, 1 over 2 root cos x square into d by dx of cot of x square. This 2 and 2 gets cancelled. 1 over root of cot x square into differentiation of cot is minus cosecant square x square into differentiation of x square is 2x. That's it. See here. 2 into differentiation of root x is 1 over 2 root x, 1 over 2 root cot x square into d by dx of cot root x, inside the root cot x square. Differentiation of cot is minus cosecant square x square into d by dx of x square is 2x. Now come to this. Here y is equal to cosecant of tan root x. Okay, let us assume this as, so differentiation of cosecant x is minus cosecant x into cot x, cot of tan root x into d by dx of tan root x. Okay, function of a function. Now this is minus cosecant of tan root x into cot of tan root x into differentiation of tan x is secant square root x into d by dx of root x is 1 over 2 root x. This is the simplified answer. Okay, hope you followed. Function of a function of a function. Now let us come to the next problem. This is very important. You may expect for 2 marks. Y is equal to sine of cos x square. Differentiate this. Dy by dx is equal to, let us assume this sin x. Differentiation of sin x is cos, instead of x it is cos x square into d by dx of inside function cos x square. This is cos of cos x square into differentiation of cos is minus sin x square into differentiation of x square is 2x. So the answer is minus 2x into cos of cos x square into sin of x square. That's it. Okay. Now let us come to this. Y is equal to cos of x cube into sin of x to the power of 5. So this can be differentiated using UV method, product rule. First function into second function. Dy by dx is equal to first function into, if you differentiate this, differentiation of sin is cos x to the power of 5 into 5x raised to 4 plus second function sin x raised to 5 into d by dx of cos is minus sin x cube into differentiation of x cube is 3x square. That's it. See here, cos x cube into differentiation of sin is cos x raised to 5 into d by dx of x raised to 5 is 5x cube plus second function sin x raised to 5 into differentiation of cos is minus sin x cube into d by dx of x cube is 3x square. That's all, product rule. Now let us come to the next problem. This is u by v, quotient rule. So dy by dx, if we call this as y, dy by dx is equal to d by dx of sin of ax plus b divided by cos of cx plus d. This is of the form u by v. Denominator cos of cx plus d, denominator into differentiation of numerator. Sin is cos ax plus b into differentiation of ax plus b is a, denominator into differentiation of numerator minus numerator sin of ax plus b into differentiation of denominator cos is minus sin cx plus d into differentiation of cx plus c is c divided by the denominator square, that is cos of cx plus d, cx plus d whole square. That's it. If you want, you can simplify. This is how we are going to apply u by v method. Now let us come to the last problem in this, differentiating with respect to x. Y is equal to sine of x square plus 1 by root x. This is also u by v. So dy by dx is equal to denominator into differentiation of sine is cos x square plus 1 into differentiation of x square is 2x minus numerator sine of x square plus 1 into differentiation of root x is 1 over 2 root x divided by the denominator square and square root gets cancelled, root x whole square root gets cancelled, x. That's it. If you want, you can divide term by term. That's it. So see, denominator into differentiation of sine is cos x square plus 1 into d by dx of x square plus 1 is 2x minus numerator sine x square plus 1 into d by dx of denominator is 1 over 2 root x divided by denominator square root gets cancelled, you will get the answer. That's it. Okay. So that's all regarding today's session. Let us meet with the different concept in the next class. Thank you very much.